All right, welcome to what's hopefully the last video of 4.4, and you're probably really tired of it because you've done a lot. I mean, 4.4 was a lot of factoring, challenging factoring, factoring that takes perfect practice. It's all normal, but this really cool thing about this part is it ties a lot of the previous stuff together, not just in 4.4, but before 4.4, like 4.1, 4.2, 4.3. What I'm talking about is page 183, numbers 10 and 11. So go ahead, turn to page 183, numbers 10 and 11, read the directions. We're taking something, a factor, or rather a potential factor, x minus 3, whatever it is, and we're seeing if it is a factor of a bigger polynomial. And then sometimes the directions are going to say factor completely if it is. So again, we're going to take something. Is it a factor of a larger polynomial? And then if it is, let's factor all the way. Now it ties into 4-1 where we talked about, is this a polynomial? And then can we evaluate a polynomial? Because turns out, by the way, let's say I gave you a factor of x minus 3. Well, change the sign like we're used to, right? And plug in 3 to the equation. If you get 0, after you plug it in and do the math correctly, do your order of operations correctly, if you get 0, then it turns out that x minus 3 was a factor. So change the sign, plug it in, just like when we evaluated, right? Plug in a random number or a number that I tell you to, see what you get. Well, if you plug in a number and you get 0, that number you plugged in, change the sign, put an x in front of it, that's a factor, which is fine. All right, right? Like we know that 12 is a factor of 48, right? But what if I wanted you to break it down all the way? Okay, so after we did 4.1, we talked about adding, subtracting, multiplying. Those are all building things up, right? But then we went into dividing. So we're going to start breaking things down, and then factoring, which breaks things down as well, usually all the way, because once we get down to all the factors, we can change the sign and get the roots, the solutions, the x-intercepts. Okay, that's where we're going with this. So numbers 10 and 11, when you show that something's a factor, and then if it is, factor completely, you're actually breaking things down all the way. And now it's handy because, let's see, the factoring that we've done to break things down. We've done the simple Algebra 1 stuff. What two numbers multiply to this and add up to this in the middle, right? So we can look at it, we can try it. We've done binomials, perfect square trinomials to binomial squares, difference of two squares, double difference of two squares, double dots, quadratic form, things that look like that first thing from Algebra 1, but instead of x squared and an x, it's x to the 4th and x squared, or x to the 8th and x to the 4th. We've done grouping, we've done cubes, difference in sum of two cubes. But what if you get something that can be broken down to its factors, but you can't identify the first step looking at it? Like you can't identify the first step looking at it. That's where we're going here. All right, but before we get there, you're going to get two different types of directions. You actually get to make a decision on what you want to do. It really is up to you. I think the second way gives you the least amount of work, but that's my opinion. So I'm going to do both ways for you. The first way is just plugging it in. Now, you only have numbers 10 and 11 on page 183. So I'm going to actually take from my teacher's edition and give you extra problems, okay? So I'm going to share my screen, and I'm going to read the directions for you and show you one way to determine if something's a factor, okay? So copy down this. So the directions, this is letter alpha. Remember, if it's in Greek, you know that it didn't come from your book, so don't go looking for it. It's going to look like page 183, numbers 10 and 11. All right, determine whether, and I'm just going to write is, determine whether x minus 3 is a factor of f of x equals x squared plus 6x minus 12. Okay. So the book's going to say determine whether, I'm just going to write it. Now, two methods. One, change the sign, so 3, and plug in 3. So change the sign, write that down, change the sign, and plug it in. Now, you might remember, one thing I say is whenever you're plugging something in, you always leave parentheses for it. Now, if we plug in 3, and we get 0, then it's a factor. If we don't get 0, it is not a factor. So f of 3 turns out to be 9 plus 18 minus 12. Well, I don't know what that is. I mean, I do know what that is, but it's definitely not 0. So x minus 3 is not a factor. Okay. So one way you can do it, you can just evaluate. Is x minus 3 a factor? To find out, we're going to plug in positive 3, change the sign, into x, into the equation. And if we get 0, good job, it's a factor. If we don't get 0, actually also good job, it's not a factor. We don't need to be biased towards factors. Now, you will also get directions that say, determine whether something is a factor of something else, and if so, factor completely. So this is where I think evaluate kind of just leads you astray. It's fine, but it's going to make you do more work. So the directions actually say, show that x minus 2, this is letter beta, by the way, show that x minus 2 is a factor. Okay, so it is a factor. If you end up doing something wrong and figuring out that it's not a factor, you're wrong, not the book. Sorry, one of the few times. Of f of x equals x to the 4th minus 2x cubed plus x minus 2, then factor completely. Now, even the book will tell you, just go ahead and plug in positive 2, and if you get 0, great, keep going, all right? Even the book's going to tell you that. And we could do that. Not that you can see this question in the book, but you see a similar question in the book. However, I'm going to tell you this right now. We've actually already practiced a couple of these problems. To show that this is a factor, let's do synthetic division and then make sure the remainder is 0. Because if the remainder is 0, it's just like plugging 2 in. Well, actually, whatever you get for the remainder is what you get when you plug in 2. But what you get for the quotient is going to be factorable, and then we'll continue factoring completely. So let's plug in 2, into the box, and we have 1, negative 2x cubed, 0x squared, 1x, and minus 2. Bring down the 1, multiply, write it here, add, 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 box the remainder. It is 0. So congratulations, we showed that x minus 2 is a factor. Now, what does that mean? All right, I see a lot of kids make this mistake. We're not solving now. This is the quotient, right? We have to write in the variables, but factor completely means that we need the x minus 2 in front. And then we can write out our quotient. X cubed plus 0x squared plus 0x plus 1. I guess I didn't need all those parentheses here. I'll cut it off. Truncate, there's your SAT word. Okay, so now, by the way, if I multiply x minus 2 with x cubed plus 1, I should get that. Right, because this is a factor, and this times the quotient, the divisor times the quotient, is the dividend. All right, but I got to factor completely. So let's bring down the x minus 2. Oh, and then what do we have right here? We have a sum of 2 cubes. So little parentheses, big parentheses. Cube root, cover it up. We're just looking right here. Square the first, square the last, squeeze, don't double. Okay, look at it. Same sign, opposite sign, always positive. And here you go. We factored completely. So now, did I know going into it that we were going to get x cubed plus 1 and then I'd have to use sum or difference of 2 cubes? No. I got a quotient and it says factor completely. So now I use my Algebra 1 skills, my difference of 2 squares, my binomial square, perfect square, trinomial, my difference sum of 2 cubes, my double dots, my quadratic form, my grouping skills. Whatever comes our way, try to factor completely. Okay. All right. Now that you did that, your job is to try page 183, numbers 10 and 11. Okay, and obviously we'll have more practice coming up